Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to talk about probably the most widely used applications of the trigonometric functions, and that is this idea of indirect distance. Right, and so indirect distance is just the name of it, but you'll see based on the calculation that this can be applied to all different kinds of things, not just this indirect distance or indirect height. Right, so let's go ahead and just set up a problem, and we'll go through actual example calculations of it in the next video. But let's just set up a problem. Let's just say that you have a tree in your yard. And this tree has gotten pretty large, and you want to have it taken down. And in order to get an accurate quote from the tree company, you need to be able to tell them how tall it is. Well, there's a problem in that around this tree, there are a bunch of very sharp rose bushes that you would prefer not to take out until you know for a fact you're going to cut the tree down. So you can't really walk up to the tree with a measuring tape and measure top to bottom, right? So is there a different way that we could approach this scenario? Well, there is, and it's called indirect distance or indirect height. And the way that this would work is rather than trying to measure the length of the tree, which I'm gonna draw over this here with this dotted line, right? This is the length of this tree, this dotted line here, right? Rather than actually measuring this line directly, because that would be difficult and potentially painful due to the rose bushes, right? What you can do is you can get your distance from the tree using something like a rangefinder, where you don't actually have to come in contact with it. Right? And then you can take the angle from the line of sight to the top of the tree. You can take this angle here. This angle right here, this is called the angle of elevation. Right, this angle between the ground, so just to be clear here, this is the ground. This is you. Let's make you a little pink dot. Right, this is you observing. This is the observer. And again, this is the angle of elevation that's caused by the difference between the ground and the angle to the top of the tree at the point of observation, right? So this distance right here, we'll call this D, right? So we know this distance, right? We use a rangefinder or something to figure out the distance that we are away from the object, in this case, our spiky tree. And we know, again, we can measure the angle of elevation here, and we can use these two pieces of information to figure out the height of the tree without ever having to trample over our roses. So what I want to do is I want to stop the video here. I know this is a bit of a shorter video, but again, just to sort of conceptualize this idea of this angle of elevation, this distance between the object that you're trying to measure and the observer, and how these two things relate. So what I want to do is quickly walk through sort of conceptually what we would do next before we go into an actual example. So given this angle of elevation and the side length d, which we know, we're going to call this height right here, which again, this dotted line is our height. This is our height. This is the height of the object we want. We can call that h. I'm going to call this angle of elevation theta, because theta is a great variable for an angle. And this distance from the object to the observer, we're going to call d, right? And so if height is what we want to know, right, we have the angle here and we have d. Well, let's just think about, given theta, what the different relationships we have are, right? We have the sine, which is opposite, which in this case would be h, over the hypotenuse, which we don't know, right? We don't know what that is, so that's out. We can't use that. All right, cosine, right, is adjacent, which is d, which we do know, over hypotenuse, which we don't know, so that's out. We can't use that. What about tangent? Right, tangent is equal to opposite, which is h, over adjacent, which is d. Ding, ding, ding. We have a winner, right? We have theta, so we can get the tangent of theta. We have the height, which is what we're trying to find. So this is h. And then we know d because we measured it again with like a rangefinder. So we have our general equation. So we're going to take tangent, right? The tangent of theta is going to be equal to h over d. Again, h is the height we're looking for, and d is our distance from that object. We can rearrange this equation just like we have so many times with so many other equations to isolate the thing we want, which is h. So h is going to be equal to the tangent of theta times the distance we are away from the object. Right, so this equation right here, right, the height of the object is equal to the tangent of the angle of observation, or the angle of elevation, times the distance you are away from that object. This equation, this is the indirect distance or indirect height equation. Hopefully that makes sense. And in the next video, we're going to go through some examples of actually using it. So hopefully that made sense. And as always, please reach out. Thank you.